So my name is Yongjian Hu from UC Riverside, and my topic today is versatile yet light-weighted recon and replay for Android. This is a collaboration work with Tanzil Azim and my advisor Liulian Nimton. So recon and replay is very useful in a variety of ways, especially for Android, like debugging and testing. So there are a lot of cases I can show you. So first, think of this example. This is a navigation app, which is very popular on almost a lot of Android device. So suppose developer adds some new features, and it's very tedious that you want to replay the navigation and you drive out to get the GPS trace. So it's better that we can get automatically replay the trace. And this app is called Shazam. It's a very cool app. So what this app did is it can try to listen to a sound and send the data to the cloud, and the cloud will analyze the audio data and tell you the name of the sound. So in order to replay this app, you have to capture or record the microphone sensors. And this app has a barcode scanner, also a very popular app. It can just scan a barcode and tell you the contents. So replay this app requires that you capture the data. So developers, if you want to automatically do replay, developers don't want to always put your phone on the desk and scan a barcode. That's not a good way. So we want to automatically debug, automatically do replay. So, and also, as mentioned in previous talk, so Android is multi-threading and event-driven. So there are cases that complex event schedule can cause bugs, and these kind of bugs are very hard to debug. So we want to use replay techniques to debug some kind of event-driven race. So yes, record and replay is very useful too, but there are a lot of challenges to replay on Android devices. For example, in these apps are sensor-driven. So like navigation, they use GPS. For Shazam, you use microphone, and for barcode scanner, it use a camera. So there are high throughput and parallel sensor streams that we need to handle. And also, timing is very essential. So if, like the navigation app, if the overhead is very high, then the speed show on the screen is different. And also for Shazam app, we have slowed down the app like 30%, and the app cannot recognize the sound. So timing is quite important. And also event order, that matters. So later on, I will show you some examples why different event order can lead to diverge in replay. So our goal is to recon and replay Android app executions. The interesting question here is at which level should we handle? So one possible level is at the grid actions. So there are a lot of grid tools like Robotium and so on. So, and also our group have developed a tool called Rerun. This kind of tool try to capture the grid event that is necessary for replay. But as I mentioned, if you do not capture the GPS, if you do not capture the sound and the camera, that kind of app cannot be replayed. And also, you can intercept the Debugging instructions. That's the replay fidelity is a bit higher, but it's also a very high overhead. And also, if you go even lower, like you want to replay every CPU instructions, that overhead is very, very high. So we have do an experiment. We try to use PingPlay, a very famous recon and replay tools for debugging concurrency applications. And the overhead is too high. According to their paper, they say it's more than 100 slowed down, even on server application. But as we all know, that mobile device are resource limited. And we have tried PingPlay on Amazon app. And when we attach PingPlay to Amazon, the app just hang there. You can almost do nothing. So we can only do 2 clicks in 5 minutes. That's not good for replaying on Android. So that's why we developed a tool called VALERA. So it's a versatile yet lightweighted recorder replay for Android. So we capture all the necessary sensors like GPS camera and the touch screens. And also we capture the event ordering. That is very important for successful replay. So our tool can run on the real phone. We do not run on the emulator because emulator has limited support for sensor data. And we do not require the app source codes. We completely work on the binary level. And we can handle complex sensor inputs. It's low overhead. And we can guarantee some kind of replay, like we can make sure that the observable state on the GRI or some other system state is the same. So here's the architecture of VALERA. Given an app, we first do binary rewriting. So for the sensor data, we do at the API level. So we can intercept the sensor API calls like GPS, microphones, and camera, so on. And also we modified the Android framework so that we can get the event trace executed. And also intercepting network is necessary because if the network data is different between recon and replay, some app cannot replay because some app using the layout is dynamic, rely on the network data. So we have to capture the network inputs. So here is the example of how VALERA intercepts the APIs. So given an APK, and also developer give us back, say what kind of API you are interested in. So VALERA can automatically scan the whole app and try to intercept the interesting APK and do binary rewriting. We use the tool Redxer. It's pretty easy to use. And also, event schedule is quite essential. So here is an example from barcode scanner. So I can show you the case. So first, the UI thread, when it tries to do decoding, it spawns a background thread. Because the computation is quite heavy weighted, it strongly suggests you do the heavy computation in the background thread so that the app is more responsive. Okay, so the UI thread spawn a new thread and open the camera, so the camera will continuously post back buffer frames. And usually the first few buffer frames is of, we call it low quality because usually you may shake your hands, so the picture is blurring, so it cannot be successfully decoded. Suppose here framework 1 is such a low quality frame, and the UI thread send this data to the decoding thread and do the decoding. And then framework 2 also come. We suppose this is also a low quality frame. And because UI threads already know that frame 1 is now decoding, so it just ignores frame 2. And then decoder thread may send back the results of frame 1, say, okay, I cannot recognize this barcode. So the UI thread show the failure information. And then suppose frame 3 come. This is a high quality buffer frame, and the decoder can successfully decode it, and the barcode information is shown on the UI. So this is a successful replay, but think of this case, and the only difference is that framework 3 come before framework 1's decoding information is back. So at this time, UI thread will ignore frame 3. But according to recording, we only record 3 frames because 3 frames already can successfully show the correct information. But in this replay case, it just shows I cannot recognize the picture. So this is called replay diverge, which is not what we want. So this case shows that event schedule is quite essential for successful replay. And how can we handle this kind of event replay, deterministic replay? Parallel work can be divided into several categories. One example is the hardware base. So they modify the hardware and they can make sure that every memory read and write are deterministic. But this is quite expensive. I think it's quite impossible for a developer just to develop a new hardware for debugging, especially for Android device. So that's too expensive. And also, there are software-based approaches, like there are VM-level tools, but according to their experiments, the overhead is quite high. They're more than 10 to 100x slowdown. And there are some user-level replay, like RigPlay and Kindle. So they only intercept synchronization, like synchronization between threads. That's light-weighted, but it cannot make sure that full replay, because there are some cases there are potential race on the memory. So this requires you to instrument every memory read and write access, but the overhead is very high. So this cannot be done on Android. So hardware approach is too expensive, and the software approach is overhead is quite high. And we want to find a sweet point that we can do on Android's event-driven model. So this is an example model of the Android event-driven system. So usually, in order to process the event, so there's a model called looper, and the UI thread is actually a looper thread. So what the looper does is it is a big loop trying to fetch a message from the message queue if it is any message is available. Then the only way background thread can communicate with a UI thread is you can use handler to post message. And also, if the UI thread or the looper thread register for some hardware event, the hardware event will deliver from the system to the message queue. So based on this, we try to do deterministic event replay on the looper level. So you can think of this. So during recording, we have 4 events, like A, B, C, and D. Then we record A. Then we send us a counter like this is 1, B for 2, C for 3, and D for 4. Then we save this event log into the disk. And during replaying, we try to reconcile the different orders. Suppose that during replay, the order is non-deterministic, and the order is B, D, C, and A. Now the controller see that currently we want to replay event 1, but B is 2 according to the log, so we save it to the pending queue. Then D also save it to the pending queue. Then we come event C, but event C is before D according to the log, so we add C here in the pending queue. Now we come A, and A's logic order is 1, so we can now execute A. Then we execute events from the pending queue, like B can execute now, C can execute now, and D can execute now. By doing this way, we make sure that all the events on the looper thread is deterministic during record and replay. And this is quite low overhead. Okay, now I will show you an example how we can debug the Tom Joyce event-driven race. So this is an activity called note activity. It can show you the detail of the notes. Suppose now user click a think button here. So what it did is it tried to synchronize on the cloud. It's do syncing. And if it is done, user can click back. And it will switch to another activity. This is news list activity. The data is the most synchronized one with the cloud. Okay, suppose now the user click the sync button in the replay, and it's do thinking. But before the thinking is done, it's probably like, for example, the network is very slow, and the user click back before the sync done, then it's a crash. So the root cause here is that the button user click is an animation, so it belongs to the node activity. But in this case, because the synchronization is not done yet, then if it is done, it tried to stop the animation. But now the user is on the node list activity, and the node list activity do not have this kind of animation, so it's a non-pointer exception. So with VALERA, we can make sure that if this case happens, we record all the schedule on the looper, so that we can make sure that in order to reproduce this race, we have to make sure the back click is happened before the synchronization is done. So there are other cases that we can reproducing event-driven race. There are, as the previous talk mentioned, there are a lot of tools, some tool recently that try to do dynamic race detection, like JoyRaiser and Kappa and Event Raiser. So I think VALERA is particularly helpful if we can combine these tools, like the Event Raiser can show you the potential race that they detect, and the VALERA can do deterministic replay. That the VALERA can do deterministic replay to show you whether this race is harmful or harmless, so that developer can fix them. So now I will show you some kind of evaluations. According to our experiments, we can replay 50 apps, most of them very popular on Google Play. Like for GPS part, the GPS event throughput is around 70, and for camera apps, the buffer frame is around 50. Also, we can see that the schedule rates, the last column, the schedule, it's quite heavy. So we see that event throughput is very high. So we need to replay that. And also for the performance, as you can see, that the performance is not very high, because it's around just 1.5 overhead. And for the log size, for the GPS, it's very slow, because for GPS we just need to record the coordinates. And for camera app, the log size is a little bit higher, because we have to store each buffer frame into the log, but it's still acceptable. And also for audios, the log size is acceptable. So to conclude, I have shown you that recorder replay is very useful for Android, but there are a lot of challenges. One is that we have to support rich set of sensors, and also timing is quite essential, and we have to handle event order schedule non-determinisms. So our approach is we develop a tool called VALERA. It's sensor-driven replay. We can replay a lot of apps with high fidelity, but with low overhead. And it's quite scalable. The developers can easily add new APIs that they want to intercept. And also, we provide the deterministic event replay, which is very useful for debugging event-driven races. And also, we can try to reproduce and verify event-driven race. So thank you for listening, and I'm ready to take questions.